everyone, welcome back to Diksha Karnataka YouTube channel, and today I am discussing the chapter current electricity. The theory part is already covered. Now it's time for me to discuss all the 1 marker questions from this chapter, MCQs and possible fill in the blanks that might come from this chapter. So there will be 30 MCQs and 5 fill in the blanks that I am going to discuss from this chapter. So without much delay, let us jump into the MCQ. But before I begin, I request you to subscribe to our channel if you have not yet subscribed, and share this channel with your friends so that our channel can grow. The growth of the channel is really matters for us to make more such free content on YouTube. Now let's start. The SI unit of current is, obviously SI unit of current is ampere, not coulomb, not Newton, not farad. Now next question. When no current is passed through a conductor, so no current is passing, so remember that no current is passed, the free electrons do not move, the average speed of free electrons over a large period of time is not zero, the average velocity of free electrons over a large period of time is zero, the average velocities of all free electrons at an instant is non-zero. So average velocity over a period of time is 0, so that is the correct statement. Okay, non-zero is not possible. Okay, so even if you consider speed or velocity, average speed or average velocity, they will cancel and it will be 0. Now next, in the absence of an electric field, the mean velocity of free electrons in a conductor at an absolute temperature T is. So the absence of electric field, no electric field is there. The mean velocity of free electrons, again it will be 0. It is mean velocity will be 0 no matter whatever is the temperature is. Mean velocity will be 0. It is independent of temperature and it will always be 0. So 0 is more correct than independent of T. So that's why 0 is a specific value. So that's why you have to mark 0 not independent of T. So even though it is independent of T, now in absence of electric field, but you have to mention that it is 0. Ohm's law is valid when the temperature of conductor is very low, very high, constant, varying. So Ohm's law, if you remember the statement of Ohm's law, if temperature and other physical conditions remain same. So that means if temperature is constant, then Ohm's law is valid. If temperature is very high or very low, or if it is varying with time, then Ohm's law is not applicable, right? So Ohm's law is applicable only when the temperature is constant. Next question, in the equation AB equals to C, A is current density, C is the electric field, then B is. So what is A is current density J. Okay, it is J. And B we do not know, and C is given as electric field E. Right, now we know there is a relationship between J and E as J is equal to sigma E, or E equals to J upon sigma. Right, now this sigma 1 upon sigma means it is sigma is conductivity. So 1 upon sigma I discussed in my theory lecture, it is nothing but the resistivity. So the value of B must be equals to resistivity. If you compare these two equations, they match, so it is basically resistivity. Next question, which of the following is non-ohmic resistance? You have to identify the non-ohmic resistance. Lamp, filament, copper, wire, carbon, resistor, diode. Now lamp filament at higher temperature slightly deviates from Ohm's law, but normally you cannot call it as a non-ohmic device. But diode, which is a semiconductor, is not a ohmic device, so it is a non-ohmic device. So diode is a non-ohmic resistance. Okay, next, the relaxation time in conductors increases with the increase of temperature, decreases with the increase of temperature, is independent of temperature. All of sudden it changes at 400 Kelvin. Now relaxation time means the time between collisions. So if you increase the temperature, the collision is more frequent. Okay, so if you increase the temperature, so electrons inside a conductor, it is colliding with other electrons and atoms. Okay, so if you increase the temperature, the electron will start vibrating more and it will create more number of collisions. So relaxation time will decrease. So if you are increasing the temperature, then relaxation time decreases. If you decrease the temperature, on the other hand, relaxation time increases. So that means you can relax for more longer of time. So it decreases with increase of temperature. So it is decreases with increase of temperature, right? Next question, with the increase of temperature, the conductivity of semiconductor increases and metals decreases. Metals increases and of semiconductor decreases. Now here we are talking about conductivity. So at higher temperature, you have to remember that semiconductors become a good conductor. We will discuss more about semiconductors in a future chapter, not in this midterm series. Some students requested that they have semiconductors in their midterm, but 99% of the students, those who watch our videos, they do not have semiconductors. What you can do, you can go and check out the videos that we did last year. If you are interested in semiconductors, Brahmastra series, semiconductors Brahmastra, you can search and you can watch that. Okay, now conductivity of semiconductor increases as you increase the temperature. It is inverse that of normal metals. So semiconductor increases and metals decreases because you are increasing the temperature. So resistivity increases for metals and for semiconductor decreases. So conductivity and resistivity are exactly opposite to each other, right? Drift velocity of electrons is due to motion of conduction electrons due to random collisions, motion of conduction electrons due to electric field E, repulsion of the conduction electrons due to inner electrons of ions, collision of conduction electrons with each other. So basically when you apply external electric field, then only the electrons present in the conductor, they starts to drift in the opposite direction, right? So it only happens when you apply an external electric field. So it is very, very important to remember that drift velocity is due to the application of external electric field. Constantan wire is used for making standard resistance. Now Constantan is a wire which is used for your resistance boxes. If you see the resistance box that you use in your laboratory, those who have started doing their lab experiments, some of you may not yet started, some of you may have started. So if you have seen resistance boxes, those resistance boxes basically have Constantan, manganese or nichrome as standard resistances. Now why so? Because it has very negligible temperature coefficient of resistance. Okay, you have to remember this. This is a specific question. Negligible temperature coefficient of resistance, that means if you increase the temperature, its resistance does not change. That means if you measure the resistance during a summer day, very hot, 40 degrees Celsius, whatever resistance you will measure, and in the cold winter, suppose 10 degrees Celsius, if you measure the temperature, you will get the same resistance. So resistance does not change with change in temperature. That's why Constantan is used as standard resistance. Not only Constantan, manganese and nichrome, these are the three materials. Okay, the resistivity of a metal wire. Now we are talking about resistivity. So conductivity we have discussed once, now we are discussing about resistivity. Increases with the length of the wire. So resistivity or specific resistance is independent of the length of the wire, right? So it does not increase, so this is a wrong statement. Decreases with the area of cross section, again it does not depend on area. Decreases with the length and increases with the cross section of the wire, again this is wrong. Increases with the temperature, yes, resistivity do increase with the temperature. Okay, resistance depends on the length and area, but resistivity depends only on two things. One is material, second is temperature. The n number of identical cells of each EMF capital E and internal resistance small r are connected in series, and external resistance capital R is connected in series with this combination, the current through capital R is. So what we have small n number of cells connected in series. Okay, so n number of cells are there. So what is the total equivalent EMF? Total equivalent EMF, each are same, so epsilon, 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 so it will be n into epsilon. Why? Because if you add same number of x number of cells in series, then they will just simply be added, 1 plus 2 plus 3 plus 4 plus like that, right? So here epsilon plus epsilon plus epsilon plus epsilon, so n number of times you are adding, so it will be n into epsilon, right? This is the equivalent EMF. Now what is the equivalent resistance? Similarly, equivalent resistance will be n into small r. Again, resistances are in series. So what is the current in the circuit? Current, basically the EMF that you have applied divided by the equivalent resistance plus the external resistance. This is the formula. Okay, so E equivalent is n into epsilon divided by nr plus capital R. Okay, now what is this value? Let's check. N epsilon divided by nr plus R, so correct answer is this one. Now don't worry, here they have mentioned E, I have mentioned epsilon. Actually this is just a font issue, otherwise it will be also be an epsilon. Okay, now next question, question number 13. Now if you have not yet subscribed, I request you to subscribe to the channel and also share this video with your friends. And if you want to download the PDF of this entire lecture, then don't forget to join our WhatsApp channel. The link of the Google Drive containing all the folders will be exclusively shared only on our WhatsApp channel, so don't forget to join the WhatsApp channel as well. If the terminals of a cell are connected to an external resistance, then the potential difference across its terminal is more than the EMF of the cell, less than the EMF of the cell. So terminals of a cell are connected to an external resistance. So if you connect the terminals of a cell across an external resistance, then what happens? The voltage across this is generally less than that of the EMF of the cell, always. Okay, so it is less than the EMF of the cell. If there is nothing connected, if no external resistance is connected, then it will be equal to EMF. Okay, if no resistance is connected, okay, if you are measuring using a special device called potentiometer, then you will get the exact EMF, right? But if you are measuring with an external resistance, then the it will be less than that of the cell. Next question. Kirchhoff's first law, that is sum of I equals to 0 at a junction, deals with the conservation of. So first law means junction rule. Junction rule is conservation of charges, right? Junction rule means conservation of charges, and loop rule is conservation of energy. In the experiment of Wheatstone bridge, the positions of cell and galvanometer are interchanged. So the balance point is, now if you change the galvanometer and cell, it does not matter, the condition will remain unchanged, because P by Q is equal to R by S condition will still hold. You can try that and draw the diagram in your notebook and you can check it. The condition of P by Q equals to R by S will still hold, so it does not matter even if you change the galvanometer and the cell. Okay, column 1 gives certain physical terms associated with the flow of current through a metallic conductor. Column 2 gives some mathematical relations involving the electrical quantities. Match column 1 and column 2 with the appropriate relation. Let's see what is in column 1. Relaxation time, drift velocity, current density, and electrical resistivity. Now some of the relationships are not properly given over here, so you have to be careful. Okay, now drift velocity is definitely cannot be any VD because drift velocity itself is here. Okay, now we can see that current density is J. Now what is current density, by the way? Current density is I by A. Current density J is I by A. Now what is I, by the way? I is NEA VD divided by A. So A cancels and you get NEVD. So whenever you see a matching question, don't be super afraid to see the things that you don't know. Rather focus on the things that you know or you can find. Okay, there are some relaxation time expression is N is tau square divided by M, so that might be little complicated for you to remember. Okay, but what you can do, you can find, okay, current density I know this is basically matching with A. Okay, so one match I have found. Now second step is to check if and one more thing, there is one more wrong is given here. This will be 1 2 3 and 4. Okay, the numbers are wrong. Anyway, so we can see that 3 is matching with A. So now we will see how many of the options have 3 matching with A. If there are more than one, then we have to check the another option that we might know. But if you see here, 3 is matching with A only once. 3 is matching with A only once. This is a shortcut trick I am teaching you. Okay, other options 3 is not matching with A, and we are sure that current density is any VD. So definitely option B is correct. In case you have two options, suppose 3A over is given over here and 3A is given also in this. Now what you have to do, you can check the last one, electrical resistivity, and see if any of the following quantities is matching. So you can see that electrical resistivity is matching with E by J. We saw that J is equal to sigma E. So sigma 1 by sigma is E by J. So that means this is basically electrical resistivity. So 20 is matching with B. Now you see 20 means 4 is matching with B. So only one such combination will be there. So you will be exactly sure that this is my answer, and you can blindly mark that. Okay, this is how you answer even if you don't know the complete matching. Okay, in fact in this question also I forgot some of the matching exactly derivations. Okay, I figure out current density and electrical resistivity, so that means relaxation time will be one of them. Definitely relaxation time will be this one, and drift velocity will be this one. How can I say? Because relaxation time cannot be related to relaxation time itself, right? So relaxation time must be option C, and drift velocity must be option D. So be smart and answer little bit smarter than others. That's how you can even match answer the following question. Now match the following questions are new addition to your previous year question bank and model question paper. So be prepared if you see some of the match the following questions coming your way. The resistance of a wire is R ohm. If it is melted and stretched to n times its original length, the new resistance will be. Okay, so if you stretch a wire, its resistance increases, and you have to remember that if you increase the length of a wire without adding any extra mass, then the new resistance will be n square times old resistance. N times means double means 2, n equals to 2, triple means n equals to 3, quadruple means n equals to 4, halved means n equals to half, 1/3 means obviously n is equal to 1/3. So same formula you can use for all the length related problem, and length related problems are not only going to might come in your midterm or final PU board, also it will come in your KCET exam. So if you are preparing for KCET exam, be sure you remember this formula. Okay, we will practice more obviously, but you can remember it right now so that it becomes easier for you. Statement based question, this is also a new type. Statement 1, when a wire is not connected to battery, then no current flows. Obviously, if you don't connect a wire, then there will be no current. Statement 2, in the absence of electric field, free electrons move randomly or does not move in particular direction. So second statement is also true, and because the electrons are moving in the random direction, there is no current flowing in the circuit. So statement 2 and statement 1 both are correct, and statement 2 is the correct explanation of the statement 1. So both statement 1 and statement 2 are true, and statement 2 is a correct explanation for statement 1. So option A is correct. Now let's move on to the next question. Question number 19. Which of the following is different from the others? Volt square per ohm, ampere square into ohm, volt into ampere, joule per second square, or joule second to the power minus 2. So volt square per ohm is basically unit of energy. If you remember, energy, not energy, it is the unit of power. Okay, volt square per ohm is the unit of power. Power is given by the formula V square by R equals to I square into R, or power equals to Vodafone Idea Y. So this is power, this is also power, ampere square into resistance, volt into ampere, again power, so this is also power. But in mechanics, power is joules per second, not joule per second square. So this is not power, so this is incorrect. Now this is anyway easy question. You can identify, okay, 3 of them are related to current, one appears to be different. But if the invigilator is smart, if the question paper setter is smart, he will keep this is correct. One of the volt ampere combination, they will give you a wrong option. Okay, so be careful about this type of questions. When a steady current flows through a metal conductor of non-uniform cross section, then the drift velocity is. So steady current flows through a metal. So now what is the relationship between drift velocity? Independent of area of cross section. Now current is given by NEA VD. So now I is constant, that means drift velocity is inversely proportional to area. You have to take it on the other side, directly proportional to the area of cross section, not directly, inversely proportional to the area of cross section. Yes, this is the correct option. Inversely proportional to the square of the area, not square, simply area, inversely proportional. This is one more question. Consider a thin square sheet of side L and thickness T. So the length is L and the thickness is T, made of material of resistivity rho. So the rho is the resistivity. The resistance between the opposite faces shown by the shaded areas in the figure is directly proportional to T, directly proportional to L, or independent of T, independent of L. Now let's see. So if you see that this is the length L, this is T. Now what is the relationship of the resistance between these two sides? Now this length, if you see, is not given. Okay, and it is not okay, it is mentioned as a square sheet. So square sheet means obviously if this length is L, then this length will also be L, right? Square means all sides are same, right? So if this side is L, then this side will also be L, and this side will also be L. Now the question is very, very interesting. Why? Because we know that resistance is basically given by rho L by A. Okay, so it is not only dependent on L. So after seeing this equation, if you see that okay, this is the length L, so it must be directly proportional to L, then you will be wrong, because you need to consider this area as well, this shaded area as well. So what is the shaded area? Shaded area is basically like a small square of thickness T and length L. So what is this area? The area is basically length into thickness, so L into T. So let's put that in this equation, and you will see that rho L divided by L into T. Now L cancels and you get rho divided by T. So rho divided by T means it is independent of L. Okay, it is not directly proportional to L. Okay, it is independent of L, but it is dependent on T. It is dependent on T as inversely proportional, not directly proportional. So obviously option D is correct. This is a very tricky type of higher order thinking skill level question, which is very common from this chapter. Now identify the wrong statement from the following. Drift speed acquired by the free electrons per unit electric field is called mobility. So mobility is defined by magnitude of drift speed divided by electric field. So this is correct statement. The conductivity of semiconductors decreases with increase in temperature, which is wrong. Conductivity of semiconductors increases with increase in temperature. We have seen that the conductivity of conductors decreases with increase in temperature. Conductors decreases, yes, conductivity of conductors decreases with increase in temperature. This is the correct statement. You can check. Alloys are widely used in construction of standard resistors. Correct. Again, now next question. A wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which one of the following statement is correct? The drift speed of electron is constant. Obviously not. The drift speed of electron increases while moving from A to B. The drift speed of electron decreases while moving from A to B. Now let's see. So one of them will be correct, right? It cannot. The option D says it varies randomly, which is would definitely be not correct. Now suppose the area of this is A, the area of this say B. Drift speed at this point say VA, drift speed at this point say BB. Okay, now we already learned one trick that area into drift speed is constant. Okay, area into drift speed is constant. If current is constant, then area into drift speed is constant. So V into A is constant. Similarly, whatever V into A for this point will be the same value for this point as well. So B into VB. So VB will be equals to A by B into VA. Now we have to see if it is increasing or decreasing. Okay, so VB is increasing or decreasing, that we have to find out. So how can we find out? If you see that value of A is smaller compared to that of B, from the diagram it is clear that A has smaller area, B has larger area, right? So B has larger area, A has smaller area. That means this value is less than 1. This is less than 1. Okay, less than 1. So less than 1 means what? This value must be less. If you multiply with VA, then the entire total value will be less than that of VA. So suppose this is say 0.5. For I am just taking one example, 0.5, VA is 10, then what is this value? 0.5 into 10 will be 5. So VB's value will be less than that of VA. So VA will decrease. VA will decrease, right? You have to understand this little small mathematics, that because the fraction is less than 1, if you multiply a less than 1 fraction with a number, the total number decreases, right? So from there we can say that the drift speed of electron decreases when it moves from A to B. So drift speed of electron decreases when it moves from A to B. Now question number 24, the resistivity of a metallic conductor dash with the decrease in temperature. So resistivity of conductor decreases with decrease in temperature. It increases with increase in temperature. Resistivity means resistance, specific resistance, right? If you increase the temperature, specific resistance must increase so that the total resistance increases. If you decrease the temperature, the specific resistance must decrease so that the total resistance decreases. Kirchhoff's junction rule is the reflection of conservation of momentum. Junction rule is conservation of energy, and loop rule is conservation of charges. The value of internal resistance of an ideal cell. So if it is an ideal, that means it should not have any internal resistance, so it must be 0. When current flows through a conductor, its temperature generally increases. Okay, normal conductor, if it is a normal ohmic conductor, then its temperature increases. SI unit of current density. Now current density is J is equal to current divided by area. That means its unit will be ampere per meter square. okay, ampere per meter square or ampere to the meter to the power minus 2. The magnitude of drift velocity per unit electric field. So the magnitude of drift velocity per unit electric field is called mobility. This is the answer. Which of the following characteristics of an electron determines the current in a conductor? Thermal velocity alone, drift velocity alone, both thermal velocity and drift velocity, none of the above. So current in a conductor is given by NEA VD. So this is drift velocity. Is there any thermal velocity present in this equation? There is no thermal velocity present in this equation. That means only drift velocity determines the current in a conductor, not thermal velocity. Thermal velocity is mean or average thermal velocity will be 0, so it will not play any role. Now let's move on to the fill in the blanks. Again, whenever you solve fill in the blanks, I always say that try to make a sense of the sentence. If it is making a sense, then you have to check whether it is correct or not. So first test is to check if it is making a sense. Second test is whether it is correct or not. So in a current carrying conductor, the net charge is, so in a current carrying conductor, the net charge is always 0. Whatever is the number of positive charges, the negative charges will be equal. So net charge must be 0. So you have to check and you have to mark it 0. The magnitude of the drift velocity per unit electric field is, so magnitude of drift velocity per unit electric field, we have already solved it in the MCQs, which is called mobility, right, which is called mobility. The SI unit of dash is ohm meter. So if you have followed my lecture yesterday, we said that a unit of resistivity or specific resistance is ohm meter. So it is electric resistivity. Okay. The resistivity of a certain metals or alloys drops to 0 when they are cooled below certain temperature. This phenomena is known as, this is a specific question. I have not discussed in the theory part, that's why I have included in the fill in the blanks. Those who are not watching fill in the blanks, they will miss out. So if you have watched till this point, please mention that sir, I have watched the fill in the blanks, I can answer this question. This is basically called superconductors. Superconductors are those whose resistance becomes 0 if you decrease it to a closer to absolute 0. Okay, so they are cooled below certain temperature. The phenomena is known as superconductivity. Superconductivity. The Kirchhoff's loop rule is based on the law of conservation of charges. Okay, loop rule is conservation of energy, and junction rule is conservation of charges, right? Now this is the end of this lecture. Now if you enjoyed this lecture, please don't forget to subscribe and like this video. I'll be back with the 2, 3 and 5 marker questions from this chapter, but before that you have to go through this video once more if you require, and definitely if you have not watched the theory, then don't wait. Theory is very short, less than 30 minutes, so don't wait and watch the theory portion as well. I'll be back till then, bye.